हेलो फ्रेंड्स, आपका निरंकारी वीडियो चैनल में स्वागत है। हम सभी इस लिंक में क्लास 12th फिजिक्स इलेक्ट्रिक चार्जेज एंड फील्ड के बारे में देख रहे थे और पिछले वीडियो लिंक में हमने इलेक्ट्रिक फील्ड इंटेंसिटी के बारे में देखा था और देखा था E इक्वल टू एफ अपान क्यू नॉट। In this video link, we will deal about a unit and dimensions of electric field. Units units and dimensions of electric field. As the electric field is force, as the electric field is the force per unit charge, per unit charge. So its SI unit is, so SI unit of electric field E equal F upon Q naught, then it becomes Newton per Coulomb. It is equivalent to volt per meter. It is equivalent to volt per meter. The dimension of electric field can be determined. The dimensions of electric field can be determined by using formula E equal to F upon Q naught. The dimension of F equal to ml t minus 2 and this is 80. It becomes m l t minus 3 and a minus 1. Now we will see physical significance of electric field. Physical significance of electric field. The force experienced by test charge Q0 the force experienced by the test charge Q0 is different at different points is different at different points. So E vector also varies from, so vector E also varies from points to point. In general, vector E is not a single vector. In general, vector E is not a single vector but a set of infinite vectors. But a set of infinite vectors. Each point or vector is associated with each point vector R is associated unique vector ER, a unique vector ER. So electric field is an example of. So electric field is an example of vector field. By knowing electric field at any point, by knowing electric field at any point, we can determine the force. We can determine the force on a charge placed at that point. The Coulomb force on a charge Q0. The Coulomb force on a charge Q0 is due to source charge Q. Is due to source charge Q may be treated as two-stage process. Two-stage process. Number first, the source charge Q. The source charge Q produces a definite field ER. Produces a definite field ER. ER at any point at R. Second, the value of ER at any point. The value of ER at any point determines the force on charge Q0 at that point. At that point, and it becomes F vector equal to ER vector into Q0 vector. Now we will see electric field due to a point charge. Electric field due to a point charge. Electric field due to a point charge. पॉइंट चार्ज के द्वारा इलेक्ट्रिक फील्ड की गणना. A single point charge has the simplest electric field. A single point charge has the simplest electric field. Consider a point charge q placed at. Consider a point charge q placed at the origin O. Q placed at the origin O. And at point P, distant R placed test charge Q naught. Then the direction of resultant force will be outside to the test charge Q naught. We wish to determine its electric field. We wish to determine its electric field at a point P. At a point P at a distance r from it. At a distance r from it, imagine a test charge q naught. For this, imagine a test charge q naught placed at point P. Placed at point P. According to Coulomb's law, according to Coulomb's law, the force on charge q naught is the force on charge q naught is f vector 1 upon 4 pi epsilon naught q into q naught upon r square into r cap. Where r cap is a unit vector, where r cap is a unit vector in the direction from Q to Q0 in the direction from Q to Q0, electric field at point P is electric field at point P is E vector equal to F vector upon Q naught, then it becomes 1 upon 4 pi epsilon naught Q into Q naught upon R square into R cap into 1 upon Q naught. Q naught से Q naught cancel हो जाएगा and it becomes F upon Q naught 1 upon 4 pi epsilon naught Q upon R square into R cap. The magnitude of electric field is the magnitude of electric field is E equal F upon Q naught, that is 1 upon 4 pi epsilon naught Q upon R square. Now we will see electric field due to a certain uppoint charges. Electric field due to a system of point charges. Consider a system of n point charges. Consider a system of n point charges Q1, Q2, Q2 dash dash Qn having position vector R1, having position vectors R1 vector, R2 vector dash dash Rn vector with respect to the origin O. With respect to the origin O, we wish to determine the electric field. We wish to determine the value of electric field at point P, whose position vector is the R vector. position vector is the R vector. According to Coulomb's law, Coulomb's law के अनुसार the force on test charge Q naught, the force on charge Q naught due to charge Q1 is that is F1 vector 1 upon 4 pi epsilon naught Q1 into Q naught upon R1 1 p का स्क्वायर into R1 p का कैप. Then electric field E1 becomes 1 upon 4 pi epsilon naught Q1 upon R1p vector का स्क्वायर into R1p unit cap. Similarly, electric field at P. Similarly, electric field at P due to point charge Q2 it will equal vector equal 1 upon 4 pi epsilon naught Q2 upon R12 का square into R12 unit cap. Hence the electric field at point P. Hence the resultant electric field due to a system of point charges with position vector R1 vector, R2 vector, dash dash Rn vector, then the resultant electric field will be E1 vector plus E2 vector plus En vector, that is E vector equal 1 upon 4 pi epsilon naught Q1 upon R1p square into R1p का कैप प्लस Q2 upon R2p वेक्टर का स्क्वायर into R2p का कैप प्लस Qn upon Rnp वेक्टर का स्क्वायर into Rnp वेक्टर का कैप. Now we will see continuous charge distribution. So friends, we will see this heading in my next videos, continuous charge distribution, and in continuous charge distribution we will see linear charge distribution, surface charge distribution, and voluminal charge distribution. Then we will see इलेक्ट्रिक डाइपोल या विद्युत द्विध्रुव के बारे में चर्चा करेंगे. और अगले वीडियो लिंक में हम लोग ये जो टॉपिक्स अभी हमने इलेक्ट्रिक चार्ज एंड फील्ड देखा, उस पर न्यूमेरिकल प्रॉब्लम सॉल्व करेंगे। तो आप सभी हमारे अगले वीडियो लिंक्स की प्रतीक्षा करें और ज़्यादा से ज़्यादा अपने ग्रुपों में इसको शेयर करें, लाइक करें और सब्सक्राइब करें, ताकि हम और अधिक एनर्जाइज्ड होकर के आपके लिए अच्छे से अच्छे कंटेंट प्रोवाइड करा सकें। धन्यवाद।